Okay, so here's what I've taught you in grade 11. When we did trig ratios, we used these little formulas, and they came from SOHCAHTOA stuff. So if you look at this triangle and we talk about this angle right here, okay, sine is so, which would be opposite over hypotenuse, okay? So this would be the y and this would be the r, the radius. If it was a circle, it would be called a radius. And cosine is adjacent over hypotenuse, so that's why you see it written x over r, adjacent over hypotenuse. And the tan is TOA, so opposite over adjacent. So that's why on this chart you would see y over x. Okay, and the reason on this particular diagram there was a 1 there, what do you think that 1 would represent with a radius? What would it connect to? The unit circle. Okay? So when we have that radius specific to the unit circle, it would equal 1. Okay? So that's something to note. Okay? We could be on the unit circle out here. We could be on the unit circle, then it's 1. We could be less than the unit circle, but specifically on that unit circle, that radius will be 1. Okay, so I think I taught you this little acronym. Do you remember this? So you're really cute, excellent. Or X-rated, thank you, excellent. So that is so you're really cute. X-rated, thank you, excellent. That's where those are all coming from. So it's a really fast way to hopefully remember your ratios, but then if you get stuck, it's just SOHCAHTOA, right? Okay, so let's write those in. So think about, so you're really cute, X-rated, thank you, excellent. See if you can write them in on that little chart using that acronym. Okay, so that is something that you're going to really have to memorize for the year. Not given to you on a formula sheet for your exam. You're going to keep using this so that it will be second nature to you by the end of the year. Okay, so that was grade 11. So grade 12, we're going to throw 3 new things at you. So the next trig function we're going to use is called cosecant. And what it is, it's the reciprocal of the sine function. So it's me flipping the sign. Reciprocation means a flip. So then it would go r over y. That's the ratio that I would use. Do you see where I'm getting that from? Because I'm just flipping the sign letters around. Okay, so secant is the reciprocal of the cos function. So I'm 1 over cos. So if I write my letters, it would go r over x, flipping the cos one around. And then to me, this is the only one that makes sense. Cotangent is the reciprocal of the tan function. Okay, so then here's what I always do to remember it. You would think the C one would go with the C, but it doesn't. So C always goes with the S. The C stuff always goes with the S. And then cotangent and tangent, that makes sense in my brain, but cos and sine, they don't make sense in my brain, so I always just remember it. C's and S's go together. Okay, got that memorized? Okay, so here's a question from your grade 11. I took it right out of the book. So there's an angle formed going through the coordinate 5, negative 12. So where would that coordinate be on a graph? 5, negative 12. And then there's an angle that goes through that coordinate. And do you remember when we always talked about angles last year? We were always connecting them to the closest x-axis, always, right? Remember that rule? When we do angles, always closest x-axis. Okay, so I'm going to construct this right triangle. On this side, I'm going to put a 5. On this side, I'm going to put a negative 12. So that means I'm going to have to calculate what the third side's length will be. Okay, what's the trick to get that third side? Anybody know the past math thing you would do? The theorem, a squared, b squared equals c squared. So on this, I'm going to suggest with trig. Here's my one sentence of suggestion. Don't put negatives into the math. Understand negatives in locations. So just do 5 squared plus 12 squared. You're not thinking about a negative 12 in the math work. Alright, so that's what you're doing to get that third side. And a radius would never ever be negative on a circle, right? That's a radius, so it will always be positive no matter what. Are you coming up with a 13? Okay, so find all 3 trig ratios. So here we go. Sine theta equals, remember your letters. So you're really, that's the letters. So you're really y over the r. Cute, so cosine. X rated, so I have to write the x and the r. Thank is the tan. Thank you, excellent. So y over x. Y over x. There we go. That's the answer. Okay, some other connection pieces. We did a lot of work with Astica last year. So this is in the C quadrant. So what should I know? The cosine trig value should be positive. Is it? Yeah. Everything else should be negative. Do you see how that connects? That's what it should come out to be as well. Okay, here we go. We were given a cosine ratio. So right away, what letter do I put here? What is cos's letters? Got them memorized? So you're really cute. X rated. And we're in quadrant 2. So where's quadrant 2 if you were to draw quadrant 2? So we're somewhere in quadrant 2 with a coordinate. there's my triangle. So I'm going to put the -3 on the x part of the triangle. I'm going to put a 5 on the radius part of the triangle. So now I need the other side of the triangle. Okay, so we talked about Pythagorean theorem. This time you're not going to add though, right? You're going to have to subtract with it because it's not the big side. So 5 squared subtract 3 squared is what you should be calculating with. I'm not using a -3 because I'm using Pythagorean theorem distances, not directions. Okay, did you get the number 4 on that? Okay, so now here's the trick. You have to talk to me about what kind of 4 is that. It's a y value, so is that a positive or a -4 based on its location? It's a y value, so it is positive, right? Okay, so the question says, find the cosecant of this angle. Okay, here's the 3-letter abbreviation for cosecant. So when you see that, that's what that is, cosecant. So what is the ratio letters for cosecant? It's the opposite of sine. So which letters? R and Y. Okay, that's the ratio for that one. So my final answer would be R over the Y. Okay, next question. We were given a secant. So which letters does secant deal with? What and what? R and a R and an X. Okay, so this is in quadrant 3. So I'm going to draw something in quadrant 3. I'm going to draw my triangle. Okay, this doesn't make sense. A negative radius. You can't have a negative radius. So that is 20, which means that was -7. Does that make sense? You can't have a negative radius. And look at where my x is. This is a negative x value, right? Do you see its location? It's a negative x value. So here's the deal. This is what it would have been, r over x, but we don't write numbers like that. You'll never see a fraction written like that. You would just see that. That's what it's just doing, because we don't write numbers with negative denominators. That's why. Okay? So know your locations. All right, I need you to get me this. So you should be doing a 20 squared subtract 7 squared in your calculator. Okay, the number that you're square rooting, does that work out nicely? I don't think so, right? It's a decimal. In this course, you're supposed to do exact values. So if it is not something that would work out exactly, you're going to have to leave it. Okay, before, obviously, the square root of 16 was 4. Boom, exact. Okay, so you're going to run into that if you see a radical. It's because it didn't root nicely, so leave it. Okay, this is a y value. So now you have to talk about location. We did the math, but what's the location? Is that a positive or a negative y value? You should pick negative because it's down. In quadrant 3, your coordinates are negative, negative, right? Left and down, everything's negative. So then my final answer. The sine ratio is what I'm asking for. I need to be writing a y divided by an r. Okay, so make sure math, don't put negatives with your math, but make sure your negatives are correct on your locations. All right? I'm going to skip the next one. We're not going to do that. You know what let's do? Let's make a triangle in each quadrant, just so you remember. Okay, in quadrant 1, positive, 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 right? In quadrant 1. If you ever have a triangle in there, that's what you're dealing with. Quadrant 2, what would be your summary about that? Negative x, positive height, are always positive. The radius is always positive. In quadrant 3, what would it all look like? Negative, negative, but then r is always positive. R is always positive. And then this would be positive and negative. So make sure that comes out on your triangles, right? Okay, yeah, so that last example wasn't anything new. This might be a little bit different. Okay, so this time it didn't tell me what quadrant, so I have to figure this out. All right, so what do I know about Astica? That's what we're going to do. So secant has a negative value. Secant is the flip of which one? Cos. So really, I know that cos is going to be negative. Okay? Where is cos potentially negative? Which quadrants could it be negative in? All are positive here, so not that one. C is positive, so it could be in those ones. I don't know. Now, it also tells me sine is less than 0, aka negative. Less than 0 is negative, so where is sine potentially negative? All are positive, sine is positive, so it could potentially be in the bottoms. So which quadrant is it for sure in now? Which one is going to work for both of them? That one, quadrant 3. So now I know it's quadrant 3. You know what I can do? I can write myself positive, negative, negative right now because I know that about that triangle, right? If you want to do that right away so you don't forget. And which letter is the 41? Which letter is the 9? So where are you going to put the 41 and the 9? The 41 would be an R value. And then the 9 would be on the X side. Okay, so then a squared b squared stuff, I think that one comes out nicely, right? Perfectly if you square root it, so that's good. Okay, final answer. It says, what's the cotangent ratio? So COT is the 3 letters that you can use for that one. And then I need what letter divided by what letter? X over the Y is that one, right? X over the Y. And I'm expecting you to not leave your answer like that. What should you do? You should 2 negatives make a positive. Okay, and that makes sense because where I am, the T, tangent should be positive. If tangent's positive, cotangent's positive. Okay, I think I'm going to skip that one. Let's try 2 more here. So we have a point on the unit circle with a y value of this, and it's in quadrant 4. Okay, so that's all I have. So this doesn't make sense on a triangle. You can't really do anything with just one side. You always need 2 sides. Is there something in that sentence that gives me anything else?
Says it's part of the unit circle.
Says it's on the unit circle, so what do I specifically know? I know that is 1. So now I have my 2 sides. Okay, so we can do 1 squared, subtract that fraction squared, or I could get you a way that you don't have to work with fractions. Would that be better? Do you know on a document when you have a picture and you drag the corner and you blow it up and then you can like shrink it, blow it up? That's what we're going to do. We're going to blow this up. I'm going to times it by 13 times bigger, enlarging. I'm enlarging it. So I'm going to enlarge it by 13. So if I times it by 13, that's going to be a 13. What happens when you times this fraction by 13? No bottom now, right? Do you like that better? Pythagorean theorem? No fractions? Okay, you can for sure do the Pythagorean theorem with the fractions. It's just not as fun, right? Okay, I guess I could have done my positive negative stuff also first. I could have even done that beforehand, understanding where that x value is heading. So your final answer is secant theta. You need your two letters. What over what? R over X. R over X. Okay, I'm just going to put a little bit of an extra question in here. It might ask for you to say, well, if the y coordinate is that, what's the x coordinate? So if I wanted the x coordinate, I would have to go back to the original. So what would be the number here on the original? Because you would have to do what? You'd have to shrink it. You'd have to go back. So then this would be a 12 over 13 on the original triangle, okay? So if it ever asks for what was the x value, you'd have to be on the original. Or if it asks for the coordinate of the point, x comma y, you'd have to be on the original. Just shrink it back down, okay? Okay, last one. Simplify this expression. So I know this is like probably the first question on the test, something like this. Okay, so I need you to give me a fraction for cosecant. What two letters? And I need you to give me a fraction of what two letters for cotangent. That's what you're going to do. So cosecant is what divided by what letter? Did you pick R over a Y? Is that the right one? Cotangent is what letter divided by what letter? Right, X over a Y. Who knows what to do with two fractions divided? What would you do with two fractions dividing? You should multiply, flip, right? Multiply, flip fractions. Then, look at this y. Y on the top, y on the bottom. So then I ended up with an r divided by an x. Which fraction does this represent? Which ratio? That is your secant. So it ended up being equal to a secant angle. And that's my final answer. Okay, so that would be your answer. If I use a theta, you're using a theta. If I use an x here, you're using an x. Be careful with your variables. So that could be an error as well if somebody used the wrong variable.